Hi everyone, welcome to Compose for Existing Apps. I'm Chris Baines, an engineer on the Android Developer Relations team.
Hi, I'm Manuel, Vivo, also an Android engineer in the Developer Relations team at Google. So in this presentation, we are going to tell you how to add Compose to an existing application and make it coexist with the view system so that you can migrate gradually. So I hope that by this time you already know what's Compose, but in case that you don't know, it's a new UI toolkit made for Android by the Google team. So now Compose is in alpha, and in alpha we released a bunch of samples just to showcase what you can do with Compose and get some inspiration from it. So in this talk we are going to show some of those examples, and there is the URL in case you want to check them out later. And so, because it's going to be about adding Compose to your existing application, we're going to see different migration strategies that you might have. And for example, the first one might be adding Compose to a new screen. This is a very common approach when refactoring an app to a new technology. So in Compose, because it's UI, pretty much will be in a UI screen. So in this case, when you do this, Compose code will interact with the view system at the edges. But another option here is that you can perform a gradual migration by having some parts in Compose and others in the view system. So for example, imagine that you have a recycle view that you want to migrate to a lazy column in Compose, or the other way around. You have a Compose screen and you want to reuse your custom view or any other view that is not available in Compose at the moment. For example, a map or a web view. And then the other option is migrating a whole screen. Maybe you are refactoring for some reason, and then you can convert it to Compose. And probably this is probably a good idea to do one at a time. And basically, this will also interact with the view system at the edges until the whole application uses Compose. So obviously, there is not a silver bullet for this. So use the strategy that works best for your project. And to show some examples of this, you can see like Jet News as a Compose-only application. This is part of the Compose samples that we released. And here also you have Crane, which is going to use Compose and the view system at the same time, as we will see later. And here, TD as well, it's an app that Chris Baines is developing, and he's actually migrating it to Compose. This is the clear example of an existing view application that is going to be migrated to Compose. And so in this presentation, we're going to see like a list of APIs or different sections that is going to help you basically achieve this, migrating your app to Compose. So the first thing that we're going to talk about is having Compose in Android views. So Compose at the moment needs a host activity or view in order to render UI. And if you want to have Compose at the root level in an activity, you don't actually need XML code. You can simply call the setContent method, which is an extension function on component activity, and that's it. You can call like, you're in Compose land, and you can call any Compose functions or code that you might have. But obviously, that's not always the case, right? And for that, we have this other composable function, Compose view, that is going to help you use Compose in any other layout in the view. So you might have it in an existing XML layout, or you can have it in a fragment or whatever you want. So imagine here that we have this existing view that we want to migrate to Compose. So we have a coordinator layout, a constraint layout, and let's say now we want to replace that constraint layout for Compose. And so basically here, we can replace it, the constraint layout and all the content within it, with a Compose view that will host the Compose code. And now, whenever you are working with this layout XML resource, for example, in the fragment, after you inflate it, you can get the Compose view and also call setContent in it, as we were doing before. And here, you just display hello Compose, whatever, and that's it. But if you want to have Compose at the root level in a fragment, you can also use Compose view without needing an XML file. You can create the Compose view in line, and that's it. You can call setContent. But things get a little bit more complicated when you want multiple Compose views as part of your UI hierarchy tree. So imagine here that we have a linear layout that has 2 Compose views and a text view. In this case, it's very important to give the Compose view a unique ID. And this is because saved instance state needs this in order to work. So don't forget about adding it. And also it's good for testing. Cool. Now that we know how to add compose to an existing view, we are going to see the other way around. We're going to see the opposite and see how we could have Android views inside compose. And for that, you have the Android view composable. And actually, this is useful in case, as I was saying before, if you have a custom view or you have a view that is not yet offered in compose. So for example, in this case, Android view will take a view block that it will take the view that you want to render on the screen, and then you will get the update callback whenever that view has been inflated. And as example, we are going to use Crane, as we saw before. And this is one of the sample apps, and it's a trouble app that is part also of the material studies. So here, this is just going to list, we're going to have a list of destinations. And when you tap on a destination, it's going to show that city on the map. So Crane is built in Compose. However, the Google Maps SDK for Android doesn't provide a Compose version of the map view yet. So we need to use Android view in this case. So imagine here in this composable, we have the map view container. We create and remember a map view. Then we can call Android view with the Lambda providing exactly that, a map view. And now in the callback, we can have code as if we were in an activity or a view. Here, in particular, we call getMap async on the view, as the Maps SDK documentation says. We add a marker, move the camera around, that's it. We don't have to do anything else. But what's even better is that you can also interact with the view and communicate between views and compose seamlessly. So for example, in this GIF that you are seeing on the screen, in Crane, we have the zoom control buttons written in compose and the map view itself, which is the interrupt thing that we've seen before. And you can see how you can interact with the map view and update it whenever you tap on the compose zoom control buttons. It's great from my point of view. So, and this is because the Android view Lambda will recompose whenever a state value that has been read in it changes. So if we had a zoom state in compose that we modify with the zoom controls composable, whenever we read it from the Android view Lambda, it is going to cause a recomposition in Android view, and it will be applied to the Android view. So that's why the map view is getting the new zoom. But this is cool if you sort of create your views in line, but that's not always the case. You might have an XML layout, for example. And in that case, you can use the Android view binding API. Obviously, this requires view binding to be enabled, and it comes in a different library, in a different artifact. In this case, UI-view binding. So here, the way to use it, you can simply call Android view binding with the inflation of the binding of your layout as a parameter, and you can access your bindings in the update Lambda. You don't have to do anything else, pretty neat. Now, the next scenario that we are gonna talk about is whenever you want to call the view system from Compose. So imagine that for some reason you need the context or the configuration. For that, we have something that we call ambience. And Nick, in the Compose by example talk that he gave yesterday, was talking a little bit about ambience. And this has the same, like with different properties. So for example, we have the context ambient to get the current context where you are on the screen, or the configuration and the view, if you need the actual view where Compose code is being rendered. So just to see a quick sample of this, let's imagine we have this code that we showed before, the remember map view, that we left it unimplemented. And so let's see what that code looks like. So as we have to do, we have to create a map view and we have to remember it. So we might have some code like this, but where is that context coming from? And the context, as you might imagine, is coming from the ambient. So we can call context ambient.current, and we can get the current context in that compose hierarchy at the moment. And that's it. But now the problem is that this map view needs to needs to go through a life cycle as any other Android view. And so FYI, do not do this. But as a naive implementation, you could see something like this, where on commit is going to be every time that map view changes. So here you can, naive implementation, do not do this. You can go through the life cycle and do on create, on start, on resume, and then on dispose. Whenever this composable is going to leave the decomposition, then we can go through the opposite callbacks. But now, don't do this. Of course, this is not going to follow the view lifecycle. And so how can we make this code better? So what we can do is we can create a lifecycle event observer and assign it to the view, or the map view in this case. And in this case, we can get the lifecycle owner where this compose code is being displayed, and with the lifecycle owner ambient, and we can get the lifecycle itself. And then in that lifecycle, we can add this map view as an observer there. And if we can take a look at the implementation of Remember Map View lifecycle event observer, on every event, we are going to let the view know that this event actually happened. So in this case, we are assigning, or we have the map view going through the actual life cycle in the view system. We are not making it part of the Compose life cycle itself. So another topic to mention here is the architecture of your app. So what happens with your current app architecture? Do you have to change anything? You don't if you don't want to. So we're actually providing helpers for libraries that integrate perfectly with Compose. So the first example we are gonna see, it's the view model function. And you can call architecture components view models from their composables. So it's gonna return an existing view model, or it's gonna create a new one in the given scope. And it will be retained as long as the scope is alive. So for example, if the composable is used in an activity, view model will return the same instance in all composables until the user moves away from the activity or the process is killed. So as an example, we have this main view model used in Crane that is just going to expose a list of suggested destinations using live data. So how can we use this from Compose? Actually, we just have to call the view model function. That's it. You don't have to do anything else. Everything is done for you. In case that you need to pass a factory to the view model function takes the factory as a parameter. So problem solved. And also, Compose comes with extensions for working with live data, Flow, and RxJava. Each of them, they are going to come on their own different artifacts. And this will register as an observable and represent the values of the stream of data as a state. So every emitted value will cause a recomposition in those places where state.value is used. So in Crane example, we are going to use the live data observe as state extension function. And as I was saying, it comes in the runtime -live data artifact. So now, because our main view model exposes our live data, we can call, or we can grab the suggested destinations and start observing it using observe as state. And in this case, whenever we pass this destination state to another composable, it will recompose when reading the state of it, the state.value field. Also, Compose has support for saved instance state, and it helps you saving your UI state when the activity or the whole process is recreated. So this is an example of how you can use it in a composable. And all data types that can be added to the bundle are saved automatically. But if you want to save a more complex data structure, there are several options. So imagine that we have this CD data class with name and country that we want to save. The simplest solution is to just use the parcelize annotation. In this way, the object becomes parcelable and can be bundled. But however, if for some reason the parcelable solution doesn't suit you, you can write your own rule using a saver, where you convert an object into a set of values that the system knows how to put in a bundle. So here we are using a list saver. So in the save lambda, we let Compose know how to convert a user object, or CD object in this case, to a list of string values. And in the restore one, we describe how to convert this list back to a CD object. Now in the saved instance state method, we can pass in the saver. That's it. No more work to do. And now I'd like to talk a little bit about testing. So if you missed the testing talk, the Compose testing talk given by Jose yesterday, I fully recommend watching that as well. I'm going to go quickly through this because it's pretty much what Jose said. So we have this rule, the create compose rule, to test our compose code. And so we use it in this way. And now we use set content for that composable that we want to test. And in this case, we can use Compose testing APIs to check that Madrid was displayed on the screen. We can assert that. But then what happens with the map view that we have there? The truth is that we can also use Espresso in this same test to check for that view to be displayed on the screen. So here we are using Espresso APIs. So the testing framework is going to plug itself into Espresso. And you can use both frameworks at the same time to test your app. In fact, Espresso will wait for Compose to become idle. But in those cases, when you need the activity rule, as we will see in a second, we use the create Android compose rule. So here we use it as we were using before the other rule. And now if we want to grab the camera position from the map itself, from the screen, we can use the activity rule scenario on activity callback. And now we can assert that the expected camera is in the right position. Cool. The last topic I want to cover before handing it over to Chris is about navigation. This is probably the top request topic for this presentation. And there is an existing navigation library, but it's only available in snapshots. And this is because it's work in progress. And seriously, it's pretty much work in progress. And so the main API to use navigation library is the nav host. And the nav host composable is going to create a new navigation graph inside Compose. And pretty much this is how you can use it. Inside it, you can add composable functions as destinations with this composable function that you see highlighted on the screen. And then you can also pass in the start destination as a parameter to the nav host. And for a more complicated example, you can get a grab or the navigation controller, calling the navigation controller and then passing it, remember navigation controller, and then passing it to the parameter to nav host. And actually, you can control the navigation graph as you wish. So for example, in this on-button click callback, we use the navigate function to navigate to another screen of that navigation graph. But let's say you're using the navigation library and you're in a nested composable in your UI hierarchy tree. We are also allowing you to access that navigation controller with the ambient nav controller. Basically, you use it the same way that we were using before. And because it's pretty much work in progress, there are a lot of things coming soon in the navigation library. So we have the nav support to pass dependencies to the nav host Lambda builder. We also have a saved view state to save each composable state as part of the backstop. Imagine like a scroll position or something like that. And also deep linking support is coming soon. And that's pretty much it from me. Now Chris will tell you more about how to use Compose in existing applications. Over to you, Chris. Chris, you're muted.
That's better. Thank you, Manu. So a big part of the Android apps that you create is the resources which you bundle in your apps. So things like strings, drawables, layouts, all the rest of it. So in this section, we're going to take a look at how you can use those in Compose, or even if you can. So the most basic and kind of common type of resource in your apps tends to be strings. So here you can see an example where we've got a label called Hello droidCon. And to use that in your composables, you would use the string resource effect and then pass it the ID. That same effect also works with formatted strings. So if you've got formatted parameters in those strings, you can just pass them in as the var args at the end of that parameter. Another type of string resource which isn't used as much these days is plurals, but you may still have them in your apps. We don't currently have support for plurals in Compose, but you can still use them. So you can actually use the context ambient, which Manu spoke about earlier, and then grab its resources. And from there, we can call get quantity string as you normally would in the view system. But anytime you kind of feel yourself reaching out for context ambient, view ambient, check if there's a better way. Because you're reaching out of Compose, there may actually be a better way of doing it. So just use it with caution. Sometimes there isn't, but sometimes there is. Next type of resource is dimensions. So say you've got like a padding DP value, which you use throughout your app. You can get it via the dimension resource effect. And then for colors, we have a similar thing, color resource. Now this works great for static colors. So if you're using the color tag in XML, but you can also load color stateless. But the trouble with this function is that it flattens color stateless. So if you've got a color stateless which has multiple states, like one for checked, one for selected, and all the rest of it, now this will actually flatten it to its default color, which may not be what you expect. So that's just something to bear in mind. And also be aware if you find yourself using this function. In Nick and I's developing themes with StarTalk, which we gave at ADS last year, we outlined a load of rules and kind of guidelines for working with the styling system. And one of those rules was to always prefer colors from a theme rather than hard-coded colors. So Compose's system, the styling is different to the view system, but the rule's still the same. Using theme colors means that the colors you reference will always work for the theme itself. So switching between light and dark, or even in Compose, we can actually have custom themes now. So make sure it works. Next up is drawables. So Compose has built-in support for multiple graphic types, such as vector and bitmaps. The main difference between Compose and the view system is that the responsibilities of drawable have been broken up. So in drawable, it's responsible for both storing the graphic data, but also knowing how to draw it. In Compose, they've been split up. So we now have an asset class and a painter. So in terms of vectors, we have the vector asset class, and that has data structures in it for doing paths and strokes and all the rest of it for a vector. And then the painter, which takes that asset and then converts it to canvas operations. And similarly, there's similar things for bitmaps. And to load these resources, we can use the vector resource effect and the image resource effect, passing in the ID of that drawable. Now, a common thing that comes up is the fact that you kind of need to know the type of drawable you're loading to use the right method. So that's different to the view system in that there is no common way to load. Another thing to note is that both vector resource and image resource will decode or parse their contents on the main thread. Now, this is similar to how the view system works. So it's not as if the Compose has suddenly got this massive performance degradation. It's not quite like that. It's the same. But what it does mean is that because we have this new UI toolkit, we now have a new way to do this. And that is, we now have async resource loading APIs. So these do all of their kind of parsing and loading on a background thread, which should help with performance. So in the case of bitmaps, instead of using image resource, we now have a new one called load image resource. And that returns a deferred resource instance. And internally, that has a state object, and that gets updated as soon as the actual image is loaded. And then once we've got that deferred resource, we can actually unwrap it and then use image or whatever we need to do, whatever composable, to actually display that asset. Now, the magic of recomposition and the fact that it's using state underneath means that we don't need to think about callbacks or anything like that. Once the resource has been loaded and the state is updated, our code will just be rerun and the image will be displayed. And a similar thing happens for vector resource as well. So instead of using vector resource, you can call load a vector resource. So the implementation I just showed you was pretty simple. It's the case of I have a drawable or I don't have a drawable, but you can actually go much more complex. So if you want to provide custom logic for, say, when the drawable is loading, you could display a progress indicator or something. You can actually unwrap the resource and then get hold of its type. And so it's a sealed class, and it has 3 types: pending when it's loading, loaded when it's done, and then failed, obviously, if it failed. So you can do that if you need to. And that brings me on to animated vector drawables. So this hasn't quite landed yet. It's actually still in a CL on AOSP. And so what I'm about to show you is a complete preview. The APIs may have actually changed by the time it lands, but it gives you an idea. Now, the reason why I've just gone into asynchronous loading APIs is that the animated vector resource is only asynchronous. There's no synchronous version. And similar to before, we have the load version, so it's called load animated vector resource. And again, we get a deferred resource back. And then we can unwrap it as we did before. Now, to display it's slightly different. We need to create, remember, an animated vector state. And that allows us to actually control the animation. Remember, this is an animated drawable. It's not just a static thing. And then we can display it. We do that by creating an animated vector painter, giving it that state. And then finally, we just start the animation. And so here we're just doing it in an on-commit lambda, so that whenever it's first loaded, it just starts. But you can imagine this could be hooked up to scroll events or, I don't know, click or whatever you need to be. But the way you do it is via calling the start function on the state. So that's vectors and bitmaps we've kind of covered. But what about other types of drawables? You might have Lottie. If you're using Lottie in your app, if you've got these complex animations, you want to use those in Compose, hopefully. And similarly, if you've written a custom graph drawable, some pie chart drawable, it'd be good if you could reuse that without having to migrate at the same time. So we've actually published a kind of experimental tool called Android Drawable Painter. And what that allows you to do is pass it in a drawable and it will paint it for you. That's basically what it does. We don't see this as like a long-term solution, since converting between a drawable and a painter is actually pretty simple. If you look at the APIs, they're actually pretty similar. But it can be helpful for migrations in that, say, you're using a library such as Lottie, which doesn't have a Compose version yet. You can still migrate with those drawables. So we mentioned Lottie. Now let's build a simple Lottie image composable. So here we're going to create a Lottie drawable and remember it, because that allows us to update it later. And then at the bottom, you can see that we're going to display it in an image by using our Android Drawable Painter. And now we need to actually load the asset, update that drawable. So here we're going to use the onCommit lambda and then take a look at that asset file name. And then whenever the file name changes, this will be ran. And then we're going to use the Lottie loading APIs. You don't need to look too much into this, but this is how it works. And then once the actual composition, the internal state has been loaded, we set it on a drawable and then call play. And then once happens, you get this. It's just the Lottie animation playing in Compose. Next up, we're going to talk about themes and styling. So one of the key pieces of guidance we recommended over the past kind of couple of years really was to lean in and use the material theming system as much as possible. So its 3 key pillars of typography, shape, and color are a great way to systematize your theme and give it some structure. And then for implementation, you would typically use the material components for Android library, which I'll refer to as MVC from now on, because that's quite long to say. And then similar to MVC, Compose offers an implementation of material design, and that includes the theming system, so those 3 key pillars. So if we take a look at this example, we're just looking at the colors right now, but you can see that we're creating a color palette based on whether it's dark theme or not, and then updating the primary and non-primary colors. And then to use that color palette in Compose, you would pass it through to material theme. And that way, any material components you use within, like deeper down the tree, would then pick up that color palette and then automatically display using your custom color palette. So this is great if you're starting from fresh with a brand new app, and it is really good. But if you're adding Compose to an existing app, you will likely be starting from something that looks a bit like this. So an existing app, like the IO app here, is likely to have quite a large theme with things such as text appearances, shape appearances, colors, default widget styles, all the other things you need to set in your typical modern Android app these days. And then when you introduce Compose, you'll then need to redefine your theme in Compose for those screens that you actually are going to migrate. Now, this results in 2 copies of the same theme in different systems, which makes it hard to maintain or update. So if you need to update a color or some dimension later, it's 2 places you've got to remember to do and not update it in. Now, this might be okay. Like if you plan to fully migrate over to Jetpack Compose in the nearish future, so we're talking like 6 months, say, you will need to eventually create that Compose version anyway. It is the future. It is the long-term goal. But for longer migrations, you're going to be slowly doing it fragment by fragment. Ideally, we would remove those 2 sources of truth and have one depend on the other. So you kind of also generate one from the other. So as we said, Compose is the future. And so ideally, we define our theme in Compose and then have it automatically reflected in the view system. Now, unfortunately, that isn't possible. The view styling system just isn't built for this. You can't modify themes at runtime. You can't create them at runtime. So therefore, it's impossible. Instead, we've published a new library called Compose Theme Adapter, which allows you to reuse your color, text appearances, and shape appearances from your MDC theme, your XML theme, in Compose. And you can get it at this URL. So we go back to our example, and instead of having our handcrafted Compose theme, it becomes a simple call to MDC theme. So it's automatically picking up those XML attributes and then use them in Compose. Now, the adapter library also allows you to customize the generated theme parameters. So say you want to tweak the colors just for our Compose elements, or you want to add some dynamic theming just in Compose, we can do that. So instead of using MDC theme, the function, you would call create MDC theme, and that passes the individual parameters back to you, and then you can customize as needed. But then the responsibility is on you to pass them through to material theme. So it allows you to do that if you need to. But be aware there are a few limitations to the theme adapter. So firstly, it only works with MDC themes and not, say, AppCompat or platform themes. So as we mentioned earlier, Compose implements material theming, and therefore, for us to be able to map between the two design systems, we need the base values to also be in material theming. So that's why we need MDC. The second limitation is it only currently reads the color, text, and shape appearances from your theme. So it's just those material theming components. And the key thing missing here is that it doesn't read default widget styles. Compose doesn't have the concept of a kind of like default style declared in your theme, unlike say the view system, so we can't map to it. And as we mentioned earlier, you can modify themes at runtime in Compose, but if you do that, it only works in Compose. Like, it doesn't automatically manage to update your view theme at the same time. It's a one-way conversion. And then finally, it doesn't handle any window level attributes, which we'll talk about in a bit. So next up is widget styles. So I'm sure that many of your apps contain styles such as this, where we have a kind of a style which extends one of the MDC styles, in this case button, and you're just going to tweak a few values. So in this style, we're just going to take the button style and add like a yellow border around it. Very nice. So how can we actually use that in Compose? Well, we can't. Compose doesn't contain the equivalent of a declarative widget style like the view system. There's no bag of properties that we can like update and stuff and update. Instead, in Compose, it becomes a bit like this. So instead, we're going to create our own composable function, which overloads the component that we want to tweak. So if we step through it, the name of our function becomes our style name becomes the name of the function. So call it whatever you want, really, but my out button seemed good. And then the parent style becomes the actual function you're overloading. So we're just going to call through to that. And then finally, any of the attributes you want to tweak. So in this case, it was stroke width and stroke color. Now in Compose, that API is called border. And so it becomes this instead. So that's the general pattern for doing styles in Compose. All right, next up are fonts. So I'm sure many of you are using downloadable fonts in your apps. Now, unfortunately, downloadable fonts aren't yet supported in Compose. So for now, the alternative is to download those font files and bundle them in your APKs. And you can do that by placing them in the font resource folder. And once you've done that, you can then use them in Compose like so, by creating a font family, referencing those font resources, and then you can apply them to your typography. But be careful if you're using the MDC Compose theme adapter. The adapter does support text appearances which use font files from your resources. But for a partially migrated app, so say you've got half views, half compose, it's quite easy to accidentally use a downloadable font and update your text appearances. And that will work in your view system, in your view UIs, but not in your Compose. So just be careful when you're doing this and make sure to test. So that's it with resources. Now we're going to talk a little bit about system UI in Compose. Now, this wouldn't be an Android development talk from me if I didn't talk about going edge to edge, my buzzword. So if you're not quite sure what I mean by that, you can check out some of our existing content. Here we've given talks ADS and blog post series. But as a very quick recap, going edge to edge means drawing behind the system UI. So primarily we mean the status bar and navigation bar. It involves 3 key steps. Now, step 2 is no different Compose, so we can ignore that. But step 3 and 1 are slightly different. So step 1, changing the system bar colors. So as we mentioned earlier, MDC's theme adapter doesn't provide any special handling of window attributes. So we need to think a little bit about how we handle attributes such as status bar color or window light, navigation bar, all that kind of stuff. So we've published a gist containing an experimental utility called System UI Controller, which allows you to change the system bar colors from your composables or app composables. So here you can see that we're calling the set system bars color function, and here we're going to set it to our surface color. Now, one of the cool things it does is that it will automatically change the color of the content, so your clock, your status bar icons, all that stuff, based on the kind of lightness of that color. So it's really handy. And again, you can check out this URL. Now, one thing you might be thinking is that you can now remove all of those theme attributes from your theme. Now, unfortunately, you still need to set those as they're used for the initial decoration of your activity, which happens way before any of your composables are run. So make sure you keep them. Now, next up is step 3, avoiding overlaps with the system UI. And that's primarily around using window insets. So Compose doesn't currently have any built-in way to handle window insets, but the power and flexibility of the modifier system means that we can build it in our apps ourselves. If you're watching the panel, Compose panel yesterday, Clara mentioned that one of the things they're thinking about at the moment is that they're trying to get out the critical path of developers, and that includes something like this. So because the modifier system is so flexible, we've been able to actually bolt on and create window inset support externally, and then you can just download it and put it in your as a file in your app. So it's cool. So that gist contains a number of modifiers which greatly simplify the handling of insets versus, say, the view system. So if we take a look at 2 examples of these modifiers in action. So the first is you can see that we have a floating action button here in the bottom right. We have 16 digits of padding, which is implemented, it's the green box and implemented as the first modifier. And then we also want to move it out from under the navigation bar, and that's implemented by the second modifier. So compound padding like this to implement in the view system was pretty much impossible. I've written libraries which try and do it, but it never works 100%. But I think this hopefully shows that the power of the modifier system can really help simplify key use cases and make it a lot easier. And then next up, we have an example of a hero image at the top of the screen. So as you go edge to edge, you'll typically want to draw behind the status bar like so. But you can see that the icons are quite hard to see now, so you want to give it some background protection. So one way we could do that is by adding a kind of spacer element behind it, which draws like a translucent color. And the one thing to note here is that we're using the status bar height modifier to automatically get to map it to the same height. Our final section, which we'll quickly cover, is about image loading. So for image loading, one way to achieve this is to use the Compose extension for Coil and Picasso image libraries, which we've published in a group of libraries called Accompanist. So you can use it like so. We have the Coil image composable. You pass it the data, the URL that you want to load, and then you can also change the content scale or the other parameters if you need, and then it will load. And similarly, if you want to use Picasso instead, there's the Picasso image component. You can also turn on a default fade animation if you wish, and when it loads, you'll get a nice fade. So that's it. If you'd like to try out migrating an app's Compose, we have the Migrating to Compose code lab for you to try. And the TV and Sunflower sample apps are being migrated to Compose as we speak. So if you'd like to check those out, feel free, or even help out. More generally on Compose, we've published a number of new samples, code labs, and docs over the past month or so, which are great, and you should check them out. And a bit of a call for help. 1.0 will be released next year, so now is the best time to try it and give us some feedback. The main concepts are mostly in, but APIs are definitely still evolving. So your feedback and feature requests can really help shape it. So you can do that on the issue tracker, or if you want to help talk to us on Slack, you can do so with that link. Thank you very much. So let's take some questions. Are any Google apps using Compose in production? Do you want to say that, Manu?
Yeah, unfortunately, there are no Google apps at the moment, but obviously there are plans to do that in the future, but not probably in the short term.
Yeah, it's still alpha, so yeah, the same rules apply. Would you advise to start using Compose already in production, or wait for beta or final releases? I think this depends on the type of app you're working on. I definitely advise to start playing around with Compose. Whether you do that on your work apps and stuff like that, I mean, I'd probably avoid that for now until the APIs are more final, or at least more stable. But definitely, as an Android developer, you should. Well, hopefully you have the time now to start looking at the APIs and getting more familiar with them. So yeah.
Cool. The next one is about view model, if they are still going to take a big part in architecture of your app in Compose. We assume that because we created view model to just have that be part of that presentation layer for the view. So in Compose, the same rules apply pretty much. You want your UI to be as dumb as possible and kind of delegate that hard work to something else. Call it view model, call it whatever you want. But yeah, view model is gonna be big in the future as well.
The next question is.
Yeah, the next one about data binding or view binding. As I was talking before, you can use view binding with Compose, with the Android view binding composable that I mentioned before. I wouldn't recommend using Kotlin synthetics because I think it's going to be deprecated soon. And so data binding is not used. Why would you use data binding if you have the full control of your composable functions and data inside the declarative style in Compose? So yeah, view binding supported, data binding is not needed. Don't use Kotlin synthetics from now
on. Next question, why aren't plurals used if there's something that we should be using instead? No, I actually think it might be a bug, so I'm going to raise it. I haven't actually done so yet, but I will do. And so yeah, I'll raise the bug to work out where.
Yeah, I think I'm using this in the Crane app. I think I filed a bug because it is not part of the API, but I mean, the APIs are still evolving, and this is a nice feature request to have. But there is no reason why you cannot build your own. Actually, that's what I did. We have any more questions? I cannot see.
It says 15, but I can see 4. Okay. Can you explain the concept of navigation in a full Compose app? Are we supposed to keep using a single activity approach, given that we won't have a fragment for each screen? How do we define a screen? Man, you want to take that, as you've been looking at this lately?
Yeah, definitely. So I think if you attended the panel yesterday, we also covered it. And basically, I think Chris gave this answer. It is, if you're in a Compose-only application, it makes sense to have a single activity. And now at the moment, depending on the different tools that you use, you might need fragments or not. But it's a completely new Compose application. There is no reason why you just use a single activity and then from now on, all composables. And your screen depends on your business logic, to be honest. And so defining a screen might be your login screen, your registration screen. And then it's true that you will have low-level composables that you can reuse across multiple screens, like, for example, a widget or that you might have in the view system, or just something that you want to reuse. So defining a screen totally depends on your use case.
What's the next one? Is Google going to provide wrappers for non-compose views like map view, so we don't have to implement it ourselves, like here? I mean, I think the team has been mostly concentrating on making sure the underlying systems work, like making sure Android Compose View works. There may come a point where we actually create those wrappers, but it may not be yet. Now, hopefully, they should be pretty simple if all of the underlying systems work great. So that's where the team have been concentrating so far.
Cool. How can I support different layouts, for example, tablets in Compose? So there are 2 answers to this. So we have the configuration ambient that you can check out in order to know that, or we have custom built-in solutions like the composable width constraints that is going to give you the width and height of the screen. And based on that, you can have reactive composables that, depending on the width, you can change how everything is laid out. So there are 2 ways to answer that. It's pretty much it. Probably we recommend width constraints. Width constraints, which is the more pure compose solution.
Yep. Next question, do you really hard code dimensions like paddings, or is there equivalent to dimension.xml? Well, actually, when you're setting values in dimension.xml, that is just a hard-coded value. And so the equivalent in Compose would be a top-level property, which sets a DP value. You can, of course, if you want to vary it based on configuration, you can actually use that configuration ambient, work out what the current configuration is, and then wrap a function around it to return different values. So that would be the way you do it in Compose.
Yep. Will navigation of Compose have enough graphs visually like XMLs in Android Studio? I cannot give an answer, to be honest, but the team is really focusing at the moment on having the right APIs built correctly. And I think the tooling will come after. So if we see a necessity from the community that you really need this, so probably we could provide some sort of solution like that. But at the moment, we're just focusing on the Compose navigation APIs.
I think the next question kind of covers the same thing. I'm getting an assertion error, blah, blah, blah. Oh, that's Kotlin synthetics. So I think actually when I was looking at this, it's actually an issue in Kotlin 1.4, and I think it's going to be fixed in 1.4.2 or 1.20 even. And so yeah, I think it's a bug which will be fixed. Next question. If there's any more.
We're supposed to be 12. Time over? I think I'm seeing on the screen.
I think we're done.
Yeah, let's wrap up. Thank you so much for joining the talk. We hope that you learned a lot, and keep trying Compose, deliver feedback, and we are all ears. We want to listen to your feedback and all the contributions that you do.
Cool. Thanks, everyone.
Thank you. Bye.